Let's study 9th standard ICSE Physics Chapter 4, Pressure and Atmospheric Pressure Numericals from Oswal textbook. Let's start with question 2. At what depth, that is the height, below the surface of water, will the pressure, the liquid pressure totally, be equal to thrice the atmospheric pressure? And the atmospheric pressure is given as 10 Newton per centimeter squared. Density of water is given and G value is also given. Hint is given. You see the pressure below the surface of water will be equal to the atmospheric pressure, which is acting on top of the water, plus the pressure due to water, that is the liquid pressure, whose formula is H rho G. Mathematically, it's written like this. Total pressure is atmospheric pressure plus H rho G, where H rho G is the liquid pressure due to water in this case. A shout out to Suhani Chaudhary for solving these numericals. This should be a rho, density. Now, density is given as 10 raised to 3 kilogram per meter cube. So that is in SI unit. But the atmospheric pressure wasn't. It was Newton per centimeter squared. So we need to convert it to meter squared. So that will be multiplied by 10 raised to 4. So totally it becomes 10 raised to 5. 1 lakh Newton per meter square, also called 1 Pascal. 1 lakh Pascal, which is indeed 1 atm at sea level. So that's the atmospheric pressure. Now the pressure at the depth is thrice of this. So it is 3 into 10 raised to 5. So now let's substitute in the formula. P is 3 into 10 raised to 5 is equal to P0, which is just 10 raised to 5, plus H rho G. H, we have to find out. Rho, density is 10 raised to 3, and value of G is 9.8. So we know everything except H. Send 10 raised to 5 on the other side. So it becomes 3 into 10 raised to 5 minus 10 raised to 5 is equal to H rho G. Now 3 into 10 raised to 5 minus 10 raised to 5 is nothing but 2 into 10 raised to 5. And send 9,800 down to get the value of H as 20.4 meters. Next sum, the fourth sum. A rectangular swimming pool of base area, this much, is filled with water to a depth of 2 meters. Calculate the pressure and the thrust. G is given and rho is given. First of all, we'll use a formula. Pressure is equal to H rho G. Height is given, rho is given, and G is given. Everything in SI units. So no tension of conversion. We get the answer in Pascal. Now they want the thrust. Thrust is nothing but the force, or rather the gravitational force, that is the weight. So that was one method. But I'm going to use a method. Pressure is equal to thrust upon area. Cross multiply it. We get the thrust as these many newtons. Sixth sum. A simple U-tube is half filled with mercury and half filled with, or rather some of it filled with oil and water in different arms. Find the ratio of water and oil columns so that the mercury level in both the cases will remain the same. That is, the pressure remains the same. So on the left hand side, I have water, and on the right hand side, I have oil. So pressure is equal to pressure. So H rho G is equal to H rho G. G remains same, so that gets cancelled. So H1 upon H2 is equal to rho 2 upon rho 1. Now rho 2 is density of oil, which is given as 900, and rho 1 is density of water, which is given as 1000. So the ratio of their heights is equal to 9 ratio 10. Understand that it is ratio of the height of water column upon oil column. So the answer should be in that order. Now the eighth sum. The diameters of the two pistons of a hydraulic machine are 5 centimeter and 30 centimeters respectively. Find the force exerted on the larger piston if the force of 60 kgf is applied on the smaller one. Definitely the force on the larger piston will be larger than 60 kgf because the principle of hydraulic machine says that a smaller force on a smaller piston produces a larger force on the larger piston, although the pressure remains the same. So if pressure is the same, then F1 upon A1 is equal to F2 upon A2. That's Pascal's law. F1 is given, F2 is to be found out, which will be greater than F1. It was in kgf, that's okay, keep it as it is. Since they have not given the value of G, no need to convert it to Newton. The final answer of F2 will also be in kgf. Now area is a circle, so it's pi r squared, where pi and pi gets cancelled and radius value is given. So substitute the value of the radii. After cross multiplying, we get the answer as 2160 kgf. Now the 10th sum. The atmospheric pressure at a place is 70 centimeter of mercury. What does it mean? Well, first of all, in English, we have to write the answer. It means that at that place, the pressure due to the mercury column of height 70 centimeter is equal to the atmospheric pressure. And then they've asked us to express it in Pascal. So again, formula is P is equal to H rho G. H is given, converted to meters. Rho of mercury is given in SI unit. And G is given in SI unit. How do we convert the gram per centimeter cube to kilogram per meter cube? Well, multiply by 1000. And then solve, you'll get this as the answer, which is very close to 1 lakh Pascal. 12th sum. The atmospheric pressure at sea level is 76 centimeters of mercury. If the air pressure falls by 10 millimeter of mercury per 120 meters of ascent, what is the height of the mountain where the barometer reads 60 centimeter of mercury? We know that as the altitude increases, the air pressure decreases. So by knowing the air pressure at a particular point, we can roughly have an idea of how high we are. I mean, at what height we are. We will use unitary method. When the pressure falls by 10 millimeter, that means we have ascended 120 meters. Now, if the pressure falls by 16 centimeter, which comes out to be 160 centimeter, what is the ascent? If we cross multiply, you get the answer as this.
Hi students, this is AJ sir. If you like this video, press the like button. If you would like to enroll for my online test series or online lectures, email me or message me on Instagram. Check the description for more information.